instruction for section 3.2 regarding parallel lines and transversals. As we saw in the previous lesson, we took a look at a specific instance of having two parallel lines when they are cut by a transversal, making sure that when we have parallels, we mark them with the additional arrows that demonstrate that these are parallel. Otherwise, we cannot make any assumption that these lines are parallel. Here we have lines A and B, which are parallel, with C that is cutting them. Moreover, I'm going to draw angles 1 and 2. In this case, angles 1 and 2 are congruent. And the reason why, and it's a little bit of debate in your book about versus being a theorem versus being a postulate. Your textbook lists it as a theorem, but it has been listed before as a postulate, showing that two parallel lines are cut by a transversal. So the corresponding angles are congruent. Now, one of the ways that we can demonstrate this is actually through a construction with a compass. And that construction kind of marries both the idea inductively and deductively that these guys are going to be congruent. Okay. All right, so let's take a look at a few things. Once again, draw our instance of two parallel lines. Drawn this way. And they are cut by a transversal. And we're going to number all the angles that are demonstrated here. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8. Now we can already see that angles 1 and 5, 2 and 6, 3 and 7, and 4 and 8 are all congruent. Why? Because they are corresponding. So let's go ahead and list those. Angle 2 congruent to angle 6. Angle 1 congruent to angle 5. Angle 3 congruent to angle 7. And angle 4 congruent to angle 8. And again, our reason here is that these are corresponding. Now we have that whole clause, two parallel lines cut by a transversal, and this is, again, an instance we're going to encounter quite often in this course. So we can't just say that any corresponding angles are going to be congruent. It only happens in the instance that we have the two parallel lines cut by the transversal. We in our previous assignment, we actually encountered corresponding angles quite often. But I'm going to suggest that we have some more things that are going to be congruent. So for example, we have angles 3 and 6. Those two are congruent, as well as angles 4 and 5. Now, the relationship here is that these are alternate interior angles. And when we have the instance of alternate interior angles, as long as we could prove it, these guys would be congruent. Well, let's do a short proof here. Go ahead, just like partition here, and let's do a quick little 2-column proof. Right? Statements and reasons. So first of all, we are trying to demonstrate that 3 and 6 are congruent. Well, we know that, for example, 2 and 6 are going to be congruent. It's not that it's given. In this case, these are corresponding angles, right? Which we know when we have two parallel lines cut by a transversal, those corresponding angles have to be congruent. Well, taking a look, angles 2 and 3 also are going to be congruent. The reason why is their relationship is that they are vertical angles. So now we can make the conclusion further that angle 3 and angle 6 are congruent. Why? It's because of the transitive property. Now we don't have to go through this every single time, right? Now that when we see alternate interior angles, in the instance of two parallel lines cut by a transversal, that means that those would be congruent. And it's because we've proven that they have this relationship, right? And you know, it kind of goes back to when we discussed in class the notion of, you know, the long-winded procedure it is to actually start a car. There's so many things going on, you know, with the combustion engine and turning the ignition cylinder to, you know, to provide spark to the engine, et cetera, et cetera. But that's never said. It's always just start the car, right? We just hand you the keys to a car. It's the same sort of thing here. We don't have to go through the same painstaking proof every single time, right? In a similar vein, we can actually do the same thing with angles 1 and 8, which are congruent, and angles 2 and 7. And those, in this case, have the relationship of alternate exterior angles. And again, we could go through that same process using vertical angles and the transitive property to demonstrate that these angles are congruent. But now we have that theorem. Works as kind of a shortcut that we don't have to go and suffer through that process, you know, demonstrating logically that these things have that relationship. Last thing we're going to have here has to do with the other concept we learned in lesson 3.1, which is that we have angles 3 and 5, and they're not congruent, as well as angles 4 and 6. 3 and 5 and 4 and 6 not being congruent, actually what they wind up being is that they are consecutive interior angles, if you recall. But consecutive interior angles aren't congruent. In this instance, right, with the two parallels cut by a transversal, these are supplementary. But of course they are. Let's go back. Let's take a look. Going back, lesson 2.6, right? It's this theorem right here. That's congruent supplements theorem, right? Which we actually proved before, right? Showing that when we have two angles that are supplementary to the same angle, they're actually congruent. Well, the same thing is going to apply here. We can use that logic, right? With the linear pair that's created, 1 and 3, we know, for example, are going to be congruent. Excuse me, 1 and 3, for example, are going to be supplementary because they are a linear pair. That's the reasoning. And 1 and 5 are congruent because they are corresponding. Therefore, we can substitute right there. And now we can say that 3 and 5 are also supplementary, and they have that relationship as consecutive interior. Therefore, consecutive interiors, conversely, are supplementary. Let's use this to solve a problem. Let's reorient our transversal cutting the two parallels. This still works. Moreover, can demonstrate the double arrow here, similar to when we had the double arc or the double tick mark, just denotes that these guys are going to be indeed parallel. So let's number some things: 1, 2, 3, and 4, 5, 6, 7, and 8. The only thing that we're given here is the measure of angle 1 is equal to 120 degrees. Well, what's everything else going to be equal to? Well, we have so many different pieces of reasoning that we could use to get us through this. So, for example, we already know the measure of angle 5. And we know that angle 5 is also going to be 120 degrees. And the reason why, and this is what's critical. I know you guys can see them, see they're congruent, but you have to explain what makes them congruent. And in this case, these guys are corresponding angles. You can abbreviate, that's fine, but just make sure that we are providing that logic. Without that, this is incomplete. If you just were to show me that 5 equals 120, that's not going to work here. Okay? We have angle 4, which we could also say is 120. We could say it for a lot of reasons. Well, clearly, angle 4 is also vertical to angle 1, but let's use one of those theorems that we just learned. And this guy's an alternate interior angle. By the way, I need to make sure that I said this guy's a corresponding angle to angle 1. This guy's an alternate interior angle, angle 4 is, to angle 5. Right? Moreover, we could say angle 8, right? Angle 8, we have a few different reasons, right? It's corresponding to 4, but also it's an alternate exterior angle to the first angle we worked with, angle 1. We haven't used that as reasoning yet, so let's go ahead and use alternate exteriors. Angle 4 also could maybe help us with angle 6, right? The thing we just talked about moments ago. These are consecutive interior angles. So we have even more to solve here. 4 and 6. Well, there we go. We could do angle 3, which would also be 60. And that guy is alternate interior to angle 6. 2 more that we have to do. We haven't done angle 2 yet, in fact. Angle 2, lots of things. Oh, you know what? Let's go old school here. Let's make angle 2 60. But guess what? He is a linear pair. Ah, that's the reason he is supplementary to angle 1. So utilized about every single reason here. Only one we're missing here is angle 7, which we also know is 60. And again, let's go ahead and just use alternate exteriors because we just talked about angle 2. So let's go ahead and relate that back. We used all the different reasons that we've learned just recently, and even an older reason that we've also used for justification. Okay. Last problem. Demonstrating for you some of the only work that I'm going to need to see from you today. So again, let's use 2 parallels cut by a transversal. Do we know these guys are parallel yet? Well, no, but they're named C and D, and it's given here that C is parallel to D, right? The 2 slashes. So here we go. We have 6y minus 3 degrees, and we have this guy's 129 degrees, and we're going to solve for y. The first step is the most important one. It's the only one where I really need to see quote-unquote work, because all the algebraic steps I'm very confident that you can complete, especially since you're always allowed a calculator, and it's this. We should be able to determine that 6y minus 3 is equal to 129. And the reason why here, what I'm going to put in parentheses is critical. Without this, you may not get full credit. These are alternate exterior angles. Once I've made that distinction, the rest should be very straightforward to you, correct? Add 3 to both sides. 6y is equal to 132. We're going to divide by 6 on both sides. So y ultimately is going to be equal to 22. And that's your answer. Without this justification, cannot get full credit, because we need to know why you thought of that, not just it was one of your magical thoughts, but that there was actually logical reasoning behind it. Your assignment for section 3.2 is posted on Canvas. Good luck.